Hi.
Can
you hear me?
Oh yeah, here I am. Okay.
Brilliant. Hello.
Yay. We have Navona. We need to tell Navona to push the share video and audio button. Share audio and video button. Oh, there she is.
I did it! Yay!
We're all here. That was so much faster than I anticipated. We're so good with technology. We've learned all the things. Yay. Okay.
How's your day going? You must be so busy.
Not as busy as usual. Busy as usual, I guess. I don't know. And I think things have gone pretty good, minus a little Zoom bombing in the morning. Enjoyed by all.
Yeah, lesson learned there. Don't post your Zoom link on a public Twitter account.
Oh man. Is it like some group that's written some script that just scrapes these and plays some pre-recorded videos, or is it like a person who's finding the link, joining, and doing like a bespoke bombing?
It must be a bot. I think you're right.
It's a bot,
Yeah.
right?
Great. Yeah.
I think it was a bot. Yeah. But we managed to kick them off, and then thank goodness this platform ended up working out. So.
Yeah. Okay. So we want to thank. Sorry. I will bring us back. Welcome to our 2 p.m. session, which I forget what I called, but I'm just the most excited for this one than anything else because we got to start with like a major round of virtual applause for everyone on the stage. Okay, not me. The other 3 people on the stage. For Grace, Nathan, and Navona, as I see making a triangle. So all 3 of these people are sadly finishing their like neuroimaging journey. They've all submitted thesis and or are defending either next week or have already defended. Actually, maybe I'll just pass it over and give you guys a chance to introduce yourselves and tell us a little bit about your graduate experience. So I guess we'll start with Grace, because you're to the left.
Sure. So I am actually defending next Wednesday in exactly a week my PhD. So I've been a PhD student in the Tiger Lab, in Erin's lab, with Aristotle Vanescos and Stephanie Amos. And we'll talk a bit more, but so my PhD I was focusing on children and youth who have early psychosis symptoms and also neurodevelopmental disorders, ADHD, OCD, and ASD, and using neuroimaging, specifically T1 weighted imaging, diffusion, and resting state to look at brain structure and connectivity associated with those symptoms, as well as using some clustering to find more homogeneous brain behavior groups within those children.
Sorry, I should not. You didn't talk about doing this panel at the same time. Right, yeah. I think you downplayed what is an amazing series of research, so we'll have to dig more back into it. On we go. But I'll leave it to Nathan to introduce himself.
Yeah, sure. So, hi, my name is Nathan. I recently finished my master's with IMS. I was also based out of CAMH with the multimodal imaging group under Dr. Ariel Grafguero at CAMH. And yeah, my research kind of looked at structural MRI images and pulling a whole bunch of MRIs from a large database called the Alzheimer's Disease Neuroimaging Initiative, and basically performing analyses to try to figure out how certain neuropsychiatric symptoms correlate with changes in cortical thickness of gray matter in patients with dementia. Basically trying to see if we can connect, what patients are experiencing to an actual underlying pathological mechanism in the brain itself. And yeah, so basically all of my stuff was structural MRI, defended my thesis in September. I am glad to be done. But I am also fun employed. So I am looking for gainful employment. If you have any ideas, let me know. I'll pass it to Navona.
Thanks, Nathan. I wish I knew anyone who had the power to hire people, but I don't really, so sorry. I'm Navona. I'm a graduate student in the same lab as Erin and Grace. So that's the Translational Imaging and Genetics Lab at CAMH. My supervisor is Aristotle Vanescos. I've been doing a master's degree and I'm finishing, well, hopefully, on Monday of next week. I'm defending. So looking forward to that. In the research as in my thesis, looked at mostly diffusion imaging in a large sample of schizophrenia and healthy controls from a data set that was actually collected at CAMH, as well as 2 other sites as part of a multi-site initiative. Many people, if you're from CAMH, have probably heard about this study. I can speak more about it later, but it's called SPINS and it was collected over 5 years. And a lot of the imaging things that I've learned actually come from sorting through multi-site data in a large data set. We also looked at these white matter features from a diffusion image in conjunction with neurocognition and social cognition using multivariate analyses. Yeah, I think that's it.
So I want to give it, before we get started, I want to give a shout out that we want to keep this as interactive as possible. So I have some questions, and I can keep going. Stop me from keep going, and feel free to like post your own questions in the chat or in the Q&A section. Word of advice: in the Q&A section, you can post your question anonymously. So if you have a like really sinking MRI question or just a general question about grad school that you don't want to attach your name to, you have an outlet. You can do it. And we really would like to keep this as interactive as possible and hear what you're interested in learning about. But back to asking these amazing graduates, soon-to-be graduates, about their research. Let's start a little bit. Actually, do you want to tell us a little bit more about the data set that you ended up using in your thesis? And what were the pluses and minuses of the data set? What might have been unique to it, or what other data sets exist? I'll hand it to Nathan to start, actually.
Okay, my data set. Oh God. One thing that I have learned over grad school is that there is nice data and there is not nice data, and even extremely large multinational databases, which you would hope have really nice data, sometimes that data is a little messier than you expect. So my particular data set was the Alzheimer's Disease Neuroimaging Initiative. And it is really interesting because, again, my project was focused specifically on patients with dementia. So I was looking at a diseased population already. And within that population, within this database, one of the things that was kind of frustrating was, I had all of this biospecimen data. So, for example, genetic information about these individuals. I had all their MRIs and fMRIs as well as PET scans for certain ones. Not everybody in a large clinical trial, though, gets all of these procedures done. Not everybody is going to consent to actually providing certain types of information. And as a result of that, when you try to actually collate your data into like a single table and try to match up this record with this MRI image taken at this time, it is sometimes really painful to do that kind of linkage. You want to do it in an automatic manner, but that requires that the missing data have some type of regular structure that's predictable. And so, even though you might know how to code, sometimes you might end up even doing some of this manually. And so that's extremely frustrating. But once you kind of push through it, and if you can push through it, life is a lot better. Once you have your clean data set, it's great. But, working off of a large data set, the bonus is having a huge amount of data. That's not making any guarantees about that data being good data.
I'm gonna wait. I don't know if I should pass it to the next person or if somebody has something to comment on in terms of missing data. Because I think actually all of you have something to say about missing data. So maybe we should hit that tangent right away. Maybe I'll ask you one thing. So when you're talking about missing data, you can talk about how you saw it and how you dealt with missing data, but also what were the features that seemed the most informative. So what are the things that you wish weren't the most missing, or what are the things that you were happiest were missing in your research? So I guess
I
what were the
guess
variables that were most critical and ended up being the most critical actually in your research?
So for myself, it was critical that I had actual MRI images from all of the people that I actually wanted to look at. The challenge was that because, again, working in a large multinational data set, sometimes for whatever reason, the first scan doesn't work out and nobody tells you why it doesn't work out. And if you're going through the patient had 3 scans that day and only one of them is good and it's not labeled properly, then the only way you can find that out is either opening the file itself and looking at it and seeing if there's a problem, or essentially figuring out some kind of mechanism to automatically identify what you hope is going to be the best scan every single time and then select that. And that's actually the strategy I ended up going with. With ADNI, I figured that, you know what, even if I pick up the wrong scan, I have enough subjects that on average it's not going to probably impact my final results. And so it was kind of a balancing the time available that I had versus what I needed to get done. And so I created a 1,000-line function in R called a deduplicator that literally went through, matched up each record in one of my tables to the actual MRI or MRI records, and then based on how many records there were and how many pairs I could match, classified them into certain categories so that I could look at them afterwards and do manual review and select the correct ones out. That was not fun. That was how I learned to code.
Navona, do you have anything to add? I think you also had missing and/or quality issues that took over a decent. So do you want to tell us the story, or are you scared to?
Which one?
Are you scared to traumatize the newbies?
I actually was pretty lucky. I didn't, in terms of the missing data, so I didn't really have too many missing data problems. In part is, I think, because the data set that I used was collected in part at CAMH and in close collaboration with 2 other sites that I actually worked with as an RA for years before joining the same lab as a graduate student. I really understood the data set that existed. I understand the notation, so nothing was really a mystery to me in terms of where the data went, which I'm sure can spook other people if they think they're getting a complete data set and it takes a long time to sort through. The analyses that I ran did require complete data, so no missing values. So we did do some data interpolation, but that was mostly, as it turned out, for the neurocognitive assessment variables from participants who sometimes declined to continue because they were too tired or so on. We didn't really have too many issues with missing imaging data. Yeah, so I was lucky in that regard.
But you did have issues with DWI quality.
Oh yes, absolutely. There's many stories there. Yeah, so I analyzed diffusion images. This has sort of a strong tradition in our lab. Unfortunately, though, by the time I started, the people who had really taken the reins of this before had sort of all moved on in a sort of cohort. So at least it felt at the time that I was using older scripts that weren't so relevant anymore to our data organization. And in many cases, the software that I was hoping to employ had been replaced by updated software, sometimes from the same groups, or sometimes people in the field have seemed to shift to another sort of processing standard. So in some ways, especially in my first months or years, when I wasn't as familiar as I am now, it was really a slog to get through. Part of the issues with the data quality stemmed from the fact that, as mentioned, the data set I was using had 3 sites. And in fact, it actually had 6 MRI scanners because this was a multi-year study. And at some point in those years, all 3 of the sites upgraded their scanner to a new model. So being able to, or being responsible for figuring out how to analyze data essentially 6 ways, more or less, took about 6 times the amount of time and was filled with errors. Some sort of, in retrospect, foolish on my part, some that I don't think I'll commit again, but some that really felt and still feel kind of intractable, given the documentation that exists for the software I was using. It's all worked out though. Yeah.
Cool. I guess as we went to a challenging part, so maybe I can ask Grace to skip right to either a challenging or a success story. Or I can just ask you to talk a little bit more. Oh, wait, we have a question. Ooh. We have a few questions from the audience.
Do you want me to dive into that one?
Yeah.
I guess maybe though I do want to just share a little bit. So I use 3 data sets in my degree for kind of each of my different papers. So yeah, I definitely have experience diving into data sets and having to kind of just maneuver and learn about them. And I think like the best thing, you just have to learn as much as you can about what's going on in a specific data set. Each data set is unique, and in general, practices are becoming better and better. And especially the whole idea of like data sharing is becoming more and more common and more of a priority. So some of the more, the earlier shared data sets, so I worked with the Philadelphia Neurodevelopmental Cohort, or PNC, collected in Philadelphia. And that's been shared for a while now. And you could just kind of like tell a little bit that it was one of the earlier ones, whereas I've also worked with the Adolescent Brain Cognitive Development Study, or the ABCD study. And that is quite nicely organized, but I would say still not perfect, and they're still navigating challenges. And so just like learn as much as you can about your data sets. And then the final data set I worked with was the Province of Ontario Neurodevelopmental Disorder Network, or the PON network, which was collected mostly in Ontario and is a multi-site study. And so I used a subset of that was collected at Sick Kids. And so that was all children with neurodevelopmental disorders, as well as typically developing children, whereas PNC and ABCD are population-based studies. So depending on what you're kind of trying to do, those can be really helpful resources for you. So in terms of to answer your question, what kind of resources were most useful in helping you stay organized and keeping things manageable over months and years of graduate degree? So I would definitely say track what you do right from the beginning, even if you end up changing systems of how you track over the years, you like learn new systems, just try and track what you do. It helps with troubleshooting and reproducing your work, especially, but I would say specific resources. GitHub is great. I'm sure you guys are talking a lot about that at BrainHack. It's a really great way to save your code and just keep it organized. What other resources have I got other than GitHub? GitHub's also really nice because it's obviously very good for code, but you can also, of course, save like text documents in there and stuff. So you can very carefully record what you're doing as well through GitHub, which can be really helpful. But you can use like really anything. There's an app or a tool called Lab Notebook online that is just designed for scientists it's just like a digital lab notebook pretty much. I think Sick Kids uses it a lot. But however works for you, I haven't got any specific resources there. Just make sure you track no matter how you do it.
So I'm going to chime in here and just say that I started grad school without knowing how to properly track things or, do anything really. And I didn't really know how to code at the start. And so as I was learning how to code, some things kind of came out to me as like, oh, this is why generally, packages have a source folder and where you put all your scripts in, and then, here's the run script that you're going to use and that kind of stuff. I didn't know that because I just didn't know how to code and just kind of did things ad hoc. And so when I look back at my old code, it's a bit atrocious at times, but that's okay because, I can kind of understand what I was reading, but I pray for the person who ever has to look at it after me because I didn't comment it properly and I didn't do certain good practices that I now know, like there's a reason you do this because you don't remember your code like months later. So I would say document things well. The other thing I would also say too, though, is I didn't have the benefit of knowing that there were certain ways of setting up your data structure or setting up what you have so that's easy to use for different programs. And the key example I'm thinking of right now, which I think we're going to discuss later today, is BIDS. And so BIDS is this wonderful little environment where, as long as you have your imaging data in this particular directory structure, you'll be able to run basically any analysis on that data structure. And that is how I actually ended up doing one or two, maybe three different kinds of analyses on the same data set, was through BIDS. Had I actually had to do this manually and set up a free surfer for my data set and then MRI QC for my data set and then something else after that would just be a nightmare. And so knowing that certain resources exist, and I'll type it into the chat, BIDS apps or the BIDS data structure, that is huge, and use it. You will thank yourself a million times later.
I don't have too much to add. Like Grace and Nathan have said, you really sort of got to put in some time and effort to doing things, I think, right, and it really pays off. One thing that I did do, and I'm glad I did and should have perhaps done more, was to actually take the time, like including like days at a time, to wrap my head around software that I was using, or to sort of familiarize myself more with the programming language instead of sort of being in a panic every time I wanted to do a one-off analysis. The other thing I would say is don't actually do one-off analyses. Have everything committed to GitHub, have everything organized, comment everything thoroughly. And I'm pretty sure this is probably pretty well known to the people who attend events like BrainHack, but I also benefited from the example of many people in the Tiger Lab and from BrainHack and so on and so forth. So I mimicked, the way that they named directory structures or files within those structures. So for instance, having things in a sequential order, being able to run them in tandem. I really like our Markdown and comparable tools for being able to render code and show visualizations in line. And then I also started using RPubs quite a bit, which is simply just a way to share a link to analyses, but which made it really, really easy to share code and output that could be difficult to share with certain people. So for instance, my supervisor easily is able to click on a link and look at images or tables, whereas he's not as likely to sit down beside me at a computer and run things in real time. I'd really recommend doing that. Yeah, RPubs, so if you want to check it out, is, oh, sorry, go ahead, Erin.
Or
Grace.
I just want to say, sorry, one thing to keep in mind about RPubs is that it is public. So there's no way to hide that. So you're kind of just publishing that. And people have to go looking for it, but it is technically public. So depending on what you're working with. Yeah. But a really cool resource. There's also, I can't remember the name of it, but in terms of organizing your code, so yeah, really great comments about just commenting your code, organizing, also naming it really helpful things, naming everything helpful things. And there's a specific tool that you can set up the structure of your repo. So you have, in general, just separating, having a separate, yeah, cookie cutter. Yeah. So you have a folder for your data, you have a folder for your code, you have a folder for your output, and are just keeping track of what you're git ignoring, say. It could just be a helpful, especially if you're just starting, it's a helpful setup to look at.
Very cool. Thank you, guys. I can't remember. I thought I had something to add. Maybe not. Oh, yeah. I just wanted to champion what Navona said because I only started it recently and I don't see as many people doing it. Literally, if scripts run in order to make your project happen, actually put the number, start your script name with a number so that it actually sorts based on the order that it's supposed to be run in the folder. You'd be surprised how much easier it is for somebody else to figure out what to do, or how hard it is to do if someone gives you access to scripts and they're just randomly in one folder.
Yeah, I'll echo that. I do that with my code now. So I'll have so I work primarily in R. I'm not a Python person, though I've since learned Python, and it's interesting. R is nice, I will say. But basically what I'll do is in my source folder. So source will contain all of my scripts I'm going to run. The first file that I need to run is literally 00_init.r, and it just loads up all of the libraries that I need and then installs missing libraries if they're not there. And then I'll have a second script that'll be like, load all the functions that I've coded out. It'll be o1_func.r, and then o2_analysis.r or run.r might be the actual running of the script itself. And why I kind of do that too is because I can actually have a separate R notebook that calls on the scripts to run within it and then produces the output there. It just makes it a little bit more legible, just because I find that if you are sourcing your scripts and then pasting the code directly in your Markdown document, it's a lot of scrolling sometimes. So that's just generally helpful, numbering and doing it by step. It does get a little bit tricky sometimes though, where essentially sometimes my supervisor would ask, oh, can you change this aspect of the analysis or that aspect of it? So suddenly I have like 00, 01, 02A, 02B, 02C, and then so forth. And it just kind of branches out. It becomes a little bit unmanageable. I haven't found the best solution for that yet, but it's just something that, at least you have the organization and those scripts, the way I design it, it'll call all the scripts before itself to make sure that the outputs exist so that it's going to run correctly. But yeah.
Yeah, I can definitely champion the 00A and the 00B every time. There's always something you need to add to the order. You never know the exact order before you get started. But no, Grace, what do you?
I just wanted to add something that I've been using in the last couple of years, but which is awesome. I also use predominantly R and code in RStudio, say, and R Markdown. And I started using the R projects. Is that what they're called? RStudio projects or whatever. And I really like that because you just pretty much like situate a project in a folder, and then it's really nice for GitHub, say, because then you can like move that around. You can download it to like other computers and whatnot, because all it needs is the path names just always like originate with that kind of project initiation. Yeah, I find it's just really nice for moving things around, and it's simpler. You also like don't have like very long path names. You just have like simple path names, and it's really easy to find and just makes things a little bit more organized for me personally.
Also, just echoing RStudio. If you're an R user, sometimes it's a little bit of a crutch if you've never used R. If you have only ever used RStudio, I've never had to use R without Studio, because you can't. It's not as easy to run your scripts, for example, on a cluster if you're reliant on having RStudio around. That said, it is an integrated development environment, and so what that means is that like you have GitHub right there, and it'll be like, this thing is changed, and do you want to send that out to like commit it, or like do you want to see what the differences are? And that kind of integration is extremely helpful, I find, especially just thinking about those earlier organization questions. Having a visual representation of what's going on in your repo and in your project is far more helpful than sometimes the command line interface that you get with vanilla Git, I guess.
Erin, I think somebody had a question specifically, I'm not sure if we answered it, about working with multiple collaborators and multi-site data.
Yeah, I think we should definitely go there. And actually, maybe you should start. You should be the one to start us off, because you already spoke a little bit to the multi-site aspects. But I know that ADNI is also a multi-site data, I think, and
Yes,
ABCD, ridiculous amount of sites. So I think we all have something to say here. But you had and multiple collaborators. Collaborators is fun. Maybe those are two different things. But I'll let you start with whatever you think comes to mind.
Sure, yeah. I can speak about working with multiple collaborators because I've had a lot of help from a lot of places, for sure. It can certainly be challenging. I think that using version control is essential, especially some of the features about looking at proposed changes and choosing to integrate them or not. I think there's a Git session in BrainHack, right, Erin? So I'm sure that will be discussed in fully in the context of another presentation.
Yeah, so we did this morning. So there's a video in the replay section on using Git, but also some Git with collaborator features in there, led by Michael. So anybody who's just learning about Git now and super excited, check out the replay section for the Git video.
Okay, that's great. Yeah, so using those features, which for me had a little bit of a learning curve, but then once learned, maybe over the course of a couple of full days, have been just so helpful, mostly in reversing my own mistakes. Yeah, very useful. Also sort of obvious things, maybe not so obvious. If you're working on a platform to have like permissions set for particular like writing over data shouldn't be something that everybody has the ability to do, especially because it can happen thoughtlessly. It's certainly not insulting not to have write permissions. In fact, I often take them away from myself without a password or something, so I don't, again, make some sort of catastrophic error. And then I guess another thing would just be setting clear expectations about who is doing what on a human level, so that there's not confusion, which always comes down to the the need for clear communication between people, and not always using cool features of software. I can pass it to someone else because I know everybody else here has also had tons of experience with multi-site data.
So multi-site data. My first advice is pray. Pray because you're praying that the people who are organizing your multi-site data know what they're doing and are aware of the common pitfalls, like people entering information into a form using never, if you have to have people insert information into a form, never have people type it into like a free-form short paragraph box. Like data validate, and also make sure that people, or even if you can, like drop down menu so that they're forced to choose certain options upon data entry. That's like at the base level something that you can deal with easily. That's just data generally. With respect to specifically brain imaging data, that is a big challenge, because you'll find that a lot of different sites will use different MRIs. So for example, ADNI is like 60 different sites, and there has to be at least like 10 different MRI machines in operation. And so once in a while, if you're lucky, the people organizing your data set, they might produce a standardized data set, which if it's available and you can use it, go right ahead and use it. It's probably going to be a lot more easier for you. They've done the work to try to make sure everything looks right. If they don't have a standardized data set, or you're for whatever reason not able to use it for your own purposes, the next best thing that you can do is, assuming you've done all your data cleaning as well as you can, is a statistical control in your actual analysis itself. So this used to be quite common in ANI analyses, is that if you're doing any type of regression modeling, you add in an additional factor for each of your files that says site, and basically you use site as a control factor, and that fixes certain things that might be happening because of site-wide differences. Although that's not always useful, it is something that you can do. If it's not enough of a problem, though, then just kind of ignore it and just hope no one asks.
If I can dive in there too. So I feel like I've been working with the ABCD data where they're really trying to do multi-site. They have 22 sites, and they're really trying to do it like as well as they can. And so one of the things you have to think about, especially with neuroimaging data, is there are multi-sites, and each scanner kind of has its own like personality. But also, if there's multi-sites, are the sequences exactly the same, or are there differences in the sequences, which can like start to really something to consider. So like ideally a multi-site study, if all the sequences are the same, and they've tried to harmonize the data as much as possible, then using like a statistical, in the ABCD, I'm just using a statistical kind of like covariate, like a nested covariate, to take into account site. Whereas other sites, we ran into problems with the PON dataset because they did a scanner upgrade, but when they did a scanner upgrade, they also completely changed the sequence they had for diffusion. They kind of jumped from single shell to multi-shell, kind of changed all their B values there. So we ended up not using that data because we couldn't we couldn't, so this was a little while ago, we couldn't harmonize it at the time. Although since then there are like initiatives to be able to harmonize data better across sites and also kind of retrospectively. So there has been some work. I know it's called the Riche harmonization method, or the retrospective harmonization, that was developed by Yogesh Rathi and at Harvard. And anyway, so that in theory is able to overcome sequence differences, specifically for diffusion. Of course, there's also differences. Yeah, there's so many like differences that could be can evolve when you're kind of working with like data from different places. One is, though, if you're processing it all exactly the same, whereas if you're processing data in a different way, even if it's running FreeSurfer or whatnot, on different computers, on slightly different, whatever, that can introduce noise that you have to take into account. So as long as like the best way is you're processing everything exactly the same, the sequences are the same, and then you kind of just like work with what you got, slowly but steadily. Yeah.
I'll add that if you're working on a multi-site and it's a small enough multi-site. What I mean by that is like fewer than 4 or 3 sites. Like if you're multi-site but you have 2 or 3 sites, it's far more likely that you actually have access to the people that are collecting your scans. And if they don't know that you have a problem with the data that they're collecting, then they won't change their behavior, and it's going to persist in being a problem. So like, get to know who is collecting your data and reach out to them if the data that they're collecting is not working for you, because otherwise nobody's going to be able to do anything with it anyways. That's only though feasible if you're working in Toronto and all of your collaborators are in Toronto, and all of the people that are collecting imaging data are reachable.
I just want to throw one more thing out there. I think it was sort of implicit in what Grace said, but just because there's a fancy new tool for something doesn't necessarily mean it will be a quick and easy implementation on our end. This might not be so for staff who have expertise in the technical skill, but certainly for students, especially for students trying to finish in a reasonable amount of time, or who are juggling multiple projects and have strict timelines. The fact that a software package exists, even one that's presented at a conference and wins the best poster award, whatever it is, doesn't necessarily mean it's something that you can easily download and have working within a day. It sounds, again, a little bit naive to hear myself say this out loud, but I kind of actually thought that was how things worked a couple of years ago when software was being released, that I could just sort of plug and go, and that is not the case. So just because a tool exists and a PI or someone encourages you to use it, maybe just be a little bit aware that it might involve some extra elbow grease.
Yeah, I think we forget, or it just seems weird that if something's published, you think that it just magically exists and the people who made it are perfect. And you forget that the people who like are collecting these data sets and the people who are building the software, they're people and they make mistakes. And sometimes they're available to answer your questions, and sometimes they're stuck in meetings all day and they can't. And it's and there's a huge variety of like what you're gonna get.
Yeah, exactly. I don't think actually there's a single piece of software that I used that didn't have some bug in it. Most of them fundamental. And in all cases, I think we contacted the authors, who then actually re-released versions of their software, which was, again, surprising to me before. I knew that was sort of par for the course.
I guess this is something similar to that. On that note, though, things break and they don't always work. But putting the effort in to understanding why it doesn't work, I find is extremely rewarding. And I think, like, a couple of years ago, I didn't know how to code at all. But anytime I found an error, I put the effort in to figure out why it was an error, and then worked back from there to resolve it and make it not an error anymore, or learned enough to be able to perhaps go down a different path. And that process of like going through and debugging, I find is instructive, because it kind of implicitly teaches you how the code works in front of you, what are the issues that are actually happening, and it gives you like a deeper understanding of what you're actually doing, instead of typing in lines of code and swapping out variables that somebody else wrote. it gives you the ability to actually take control of what you're doing and change it so that it works. And so the example of this that I can give is there was a analysis platform called Civet, which is essentially a structural MRI analysis platform that cuts out cortical thicknesses and allows you to measure that cortical thickness. It's very similar to FreeSurfer, but it's like, and they do essentially the same thing, but slightly differently. And there was a function that was available in something called RMINC that would allow me to analyze my Civet brain images using something called a mixed model. But that function that was brought in RMINC that provided this mixed model wasn't able to work on my particular data because my data was also something called stratified. It was, I had to sort it in certain ways, and I needed to do my analysis in certain conditional, with certain conditions attached to it. And so I actually had to go into the RMINC documentation, pull up the actual function that produced this mixed model, dig into the actual code for it, and modify it. So I added an additional argument into it so it'd get passed through to the right thing in the end. And just knowing that I could do that, someone had done most of the work, but I needed to make this small modification of the code. I wouldn't have been able to do that if I didn't know how to just debug things and just work through the code and understand what I'm reading and how it's spitting back to me. So always try to debug when you can. Don't waste too much time on it. There's a point where you need to give up. If you're seeing a seg fault in your code, that's probably give up and let someone else deal with it. But if it's this should work in theory, why is it not? Doing that minimum effort, spending maybe an hour just to figure out why it didn't work, you might come across an actual solution that will make it work.
A lot of coding is just troubleshooting, and things fail until they don't.
It's 20% writing code and 80% debugging. Actually, it's worse when I get code that works the first time, because I'm always like, no, that shouldn't have worked. Or, oh God, it's probably done something horribly wrong in the middle and, converted a vector into a matrix or something like that. And now it's just pretending like it worked. Yeah.
Yeah, that's also something I feel. The one thing about code or data sets that are being used by multiple people is that there's multiple chances for somebody else to find the bug. That's the major goal of why open source, I think, is doing a lot for our field. Just we're making less mistakes. We're finding other people's mistakes more quickly, in a way that we weren't before. Wait. Okay. So, in the absence, I want to ask, because we've focused on maybe the scary parts of grad school. So to not scare people away from grad schools in science, what was one of the most rewarding parts of your thesis or of your graduate experience, or what sparked joy?
I can say something, I guess. One thing that was really exciting for me after, really trudging through some hard stuff was to step back a little bit and engage in collaborations on similar projects with other groups, which was something, our lab and my PI, Aristotle, encouraged, which was amazing. And that was really integral, I think, to, in a sense, my self-confidence. I realized that in these groups with people who didn't have exactly the same training as me and go through exactly the same experiences, they recognized what I had sort of figured out as some level of expertise, which was, incredible. And of course, I also got to learn new things from them as well. So one example that I have in mind, which several people in the lab, Michael, if he's here, and others contributed to, was an open call just that we saw on Twitter to basically perform comparable analyses to the ones that I was doing for my thesis, but in some other public data set. And that experience, led to a co-authorship, some new relationships with people that I've since corresponded with who have helped me sort things out and have continued to include me in other projects. It was just all around a great thing, and I really recommend it to everyone who can do it. And I think probably everybody can do it because, these things are just more and more common.
It's a great plug to join in on a random BrainHack project. Yeah, because sometimes you don't know. It's these side projects with new collaborators that really end up motivating you to keep going forward. Yeah, and I have to say, post BrainHack, like other online conferences, like not online conferences, real life conferences. Remember those? They were like summer camp. It's like so exciting to see your friends again in June and like find out what they were doing for the year and like go for dinner. Because they really do feel like your friends. And you guys are my friends too. I'm gonna miss you so much. So wait, Grace, do you have a positive note to bring?
For sure, yeah. There's lots of frustrating things about grad school, but there's also a lot of positives. And yeah, like it's kind of interesting now, kind of coming to the end and reflecting a little bit. And I used to be really frustrated. I felt like I did a lot of things, like side things that didn't end up like contributing to my main publications or whatnot. And that used to really frustrate me. I wish I'd like been a little bit more like streamlined. I would have, crank things out a little bit more. But kind of reflecting on it, I'm like one of the most positives is like it's this really cool opportunity where to just like learn and just pursue whatever you want to pursue. You have a lot of freedom to just like follow your curiosity. And one of the kind of most exciting things about grad school is kind of that as well. But another thing is just like being inspired by all the amazing research around you. There's so much cool stuff going on, and being able to see that research and think about like how can you integrate these things. And we're talking about how like tools and packages don't always work, but sometimes they do, and they're always like a really good starting step there, and just thinking about how to integrate them. I would say like the people for sure, like having a great lab and getting to hang out with wonderful scientists, including yourselves, and learn from you guys has been a huge highlight. And I'm gonna miss you guys as well a ton. Yeah, I'll leave it there. On to you, Nathan.
Yeah, I guess a positive for me walking away from grad school, I think the thing I cherish most is the ability to just like take on a problem and analyze it and then solve it. And like with like code especially, I think, I guess I would make an analogy to if you ever did like grade 12 physics or first year physics in undergrad and you learned about how centripetal motion worked and how like in when things are spinning in a circle, the force arrows point inwards, they don't point outwards, and it kind of changes the way you kind of see how the world works. It gives you like a physics perspective on like, oh, like yes, free body diagrams. This is where forces move. This is how things move. And the same thing kind of happened to me when I worked with like learning how to code over grad school and then taking these skills and applying them to wherever. Sure, I learned it and applied them to my specific thesis project, but I was also able to work on COVID data or like schizophrenia data or any number of data sets, and it made it so that my laptop or my computer was no longer like a black box that I had to click buttons on to get through things. Like I'm fairly confident now that I can pull up the terminal and just do literally everything I need to do on the computer, almost to the point where I'm like, I don't know how people use their computers without knowing how to, do basic things in terminal, or just taking terminal and using that to like move files quickly by wildcards, just functionally becoming a useful human being when you're using the technology in front of you. And that is something that I'm taking away as an extremely valuable skill, something that I think I can apply pretty much anywhere. Yeah, and I have been able to, so it's huge.
Yeah, so we got to all the happy and sad feels. I realized I got away from the general like science advice, so maybe we'll bring it back for a second. So very quick countdown for your thesis. What modality did you use? What pipelines did you use to get features from those modalities? And what quality assurance steps did you need to look out for when you use those pipelines? So what were the things to look out for to know that you shouldn't be including that feature in your data, or that data was poor quality? People are making notes now. Grace, because you're not looking down, I'll let you go first.
I said that is a loaded question full of lots of things. One sad thing, backtracking a little bit, is missing data. We kind of talked about, I think like the most important with missing data is to identify you have missing data and then carefully look at like who are you excluding because of that missing data, and because that is like biasing your sample, which is like, okay, like what are you going to do about it? It's fine. But like in young samples, like children move more, the like motion is correlated with age, so younger children tend to have higher motion, and so they get kind of kicked out. Same with children that have greater psychopathology or higher psychopathology, they tend to move more, and so are often kicked out. So just keeping in mind that we might be often kind of biasing our samples to exclude the children that have the most severe symptoms there. So anyway, side note there. Okay, what did I include? I used FreeSurfer, I used fMRI Prep, I used MRI QC. I just list a lot of things. I also use Maggot Brain as a really interesting, like maybe some things that are a little like less known. So Maggot Brain is a really interesting automated like parcellation tool, and they have atlases, especially for subcortical regions. And it's just like a nice alternative, especially for like sub-regions or subdivisions of like the thalamus, striatum, hippocampus, etc. It's a really nice imaging tool that is based off of your individual sample instead of necessarily using, it does use originally an atlas, but anyway. Yeah, that one's a little bit different. Then what did I do? Anything else exciting? We also, in our lab, we use slicer tractography. You can also use track-based spatial statistics and the Johns Hopkins Atlas. But we could dive into what is preferred. Depends on what you're doing, but in general, that's a whole discussion. But yeah. And what's the advice part, the things to look out for? I think just choose your, there's a lot of different options. It's pretty exciting because there's a lot of work going into, there's so many different like processing steps you can take, but then there's a lot of work right now of different groups that are trying to put that together into like a reproducible pipeline, which is pretty exciting. So start with those pipelines. People have put a lot of work into them instead of trying to kind of piece together your own pipeline. And then depending on what you're trying to do, you can alter it or add things, etc. Another thing we could talk about is like volume-based versus surface-based analyses. You should just do surface-based analyses. Check out Siftify. Smoothing is another thing we could talk about. Smooth less rather than more. Depends on what you're trying to do though as well. Yeah, was that helpful? I should write some things down. I should start by writing things down.
Grace mentioned diffusion, which I could speak to in a little bit more detail if you guys want. Yeah, so, and I think also it was presented by Jacob in a slide or two in the former presentation, but yeah, so we have a DWI acquisition, we fit a tensor, so now we're calling this DTI or diffusion tensor imaging. In my case, we perform deterministic tractography, so we're computing like the probable axonal trajectory in like one direction. We made all of the decisions about every waypoint that could be taken based on like looking at our data at every step. Maybe this wouldn't be done by people who are more expert in the field, you know, to avoid sort of cherry picking. But in this case, it was part of, you know, my sort of training to look at different ways of computing tractography and so on and so forth. So I did use multiple different software programs and approaches. We ended up choosing UKF. So if there's anyone here interested in tractography, we used unscented common unscented common filter tractography, which is from the same group actually that produced the white matter analysis software that I think Grace spoke to from the O'Donnell Research Group, or you know, colleagues of the O'Donnell Research Group at Harvard, who our lab actually has a close collaboration with, so we were able to get extra help to implement their existing pipelines, which I think are some of the best of the ones that I've come across in terms of the thoroughness and clarity. We ended up getting, you know, outputs from, in our case, 72 different tracks across the entire brain and did a whole bunch of analyses. In relation to Aaron's question about quality control, we also went off the deep end in looking at the data quality. So the data quality was like a three-pronged process, looking at different images that we got at different points. So we looked at QC of the raw diffusion data, after fitting the tensor, and then after performing tractography, and all of those included multiple steps. For the DWI and DTI data, we pulled available metrics from Eddie Quad. I'm not sure if maybe somebody else was speaking about that in some BrainHack presentation, perhaps. But this is an example of an existing standardized pipeline that we could apply, and we sort of pulled metrics from it. And we did a really cool analysis in this group that we got together in our lab and beyond of people that were interested in diffusion imaging, and we actually compared thresholds that we could set for data quality on the basis of these automated metrics that we could easily extract, and compared it to human raters. And we found that we were able to get like super high agreement, almost perfect overlap in specific data sets. So unfortunately, it didn't hold across data sets, but when we set data set specific thresholds on the basis of these automated metrics. And this is really helpful because even though we ultimately looked visually at every single thing, it was good to know that there was some agreement with, you know, what felt like real metrics. I'm not sure if anybody is too interested in hearing more about the Eddie Quad things, but this is just features that like are pretty common, like absolute motion, relative motion, SNR, CNR, outliers, noise. I think we also included something from MR tricks. Yeah,
So,
and sorry.
So Shireen asked a specific question about tractography, about whole brain versus selected tracks. So maybe you want to say a little bit about white matter analysis and how that ended up working.
Okay.
Question.
Sure. So the question was if we do whole brain and then select the tracks, or if you do targeted tractography. I think it depends largely on your data set and your question. So in our case, we did whole brain tractography and then selected the tracks. This is because we really wanted to use an automated measure that was available to us via using the Slicer software and the white matter analysis software that operates within Slicer. This is so we didn't actually have to do like draw ROIs by hand, which would have been time consuming for our data set size of around 450 people. In other cases though, certainly if people are looking at a tract that's hard to segment, or in a small number of people, or perhaps in people with some sort of pathology, it might be preferred to draw an ROI, perhaps in combination with an expert, in just the tracks of interest.
I guess going back to Aaron's question earlier, my kind of modality and pipelines and QA. So I was working on T1 weighted images. These are structural MRIs, so it was pretty chill. Although I did actually also work on PET images, which is not fun. PET is a very dirty data source. But anyways, so I was using T1 MRIs to do structural analysis, and the pipelines I was using, they kind of varied. Everything from like actual data processing pipelines, something called B-pipe, for example, allows you to automatically go through and do a number of very common corrections to your images, something called N4 inhomogeneity and N3 homogeneity, basically making things like the white matter and the gray matter, the color of it or the intensity of it match across the entire image, because for whatever reason, certain parts of an MRI scanner, for example, might just produce darker parts of the image, and that screws up your downstream analysis pipelines. So that kind of stuff. Other things I was using obviously was BIDS as well. To actually do my cortical thickness analysis, I had cortical thickness and subcortical volumes. I actually did I computed this 3 different ways, which was really annoying. But I'm really glad that I got the same result across all 3. My advice here, though, is like the reason I did it 3 different ways is because I didn't know there was an easy way to do certain things until later. But the first way I did it was Civit, so that's like a proprietary software that is run out of Montreal that lets you get really nice like voxel-wise cortical thickness maps. You can also use FreeSurfer, which is very widely available and continuously developed. That one's great, and it was great because I could use it with bids, and so it was easy for me to send my data through it. The other one I also used was Maggot. Maggot is multiple anatomically generated something kind of atlas thing. Basically, it cuts out the subcortical gray matter, and gives you a size for it. And for all these different techniques, you have to do quality assurance for each of them. So I actually built out, in the case of Maggot, I built out a custom quality assurance program for myself where I would create GIFs of each of my images and then have that GIF play for me so I could see the like cut out of the actual structure against the MRI image and then rate each of these. That took so much time, and I don't recommend that. And that's something I always consider now is like, is this scalable? Even if I could run this pipeline all the way through, is this something that is reasonably done in a time that is definite? So that's something to consider. But moving then to quality assurance, the big tools that I used were MRI QC, which basically QCs just quality control for your MRI image itself. Pretty useful for picking up things like, oh, for whatever reason, this image is all black, or this image is empty, or whatever. And you just don't know sometimes when we have 600 or 1,000 subjects, and you don't have the time to individually open each of them. So MRI QC is great. Visual QC is another one by Ramana, but that one's nice because it'll give you the actual overlays of your FreeSurfer outputs on top of your MRI images, and so you can actually see the like correspondence between how well your FreeSurfer outputs correspond to the actual MRI image, and then you can rate things from there. Obviously, that's still manual, so if you want an automated method, the one I use for myself is something called Koala-T, QOALA-T. It's an automated random forest model that works on the outputs of your FreeSurfer. So this is key for me because I had 600 FreeSurfer outputs, and I didn't have the time to go through and map them onto the image and make sure that they were correct. So what I did instead was, through this machine learning algorithm, I took my data set, divided them by severity of disease, and then took like 20 or 30% from each of those groups, created a manually rated training data set that I trained the model on, and then I tested. I used the rest of my data as the test sets, and what this would do was it provided me with an automatic rating for each of these images, essentially saying, oh, this one you should probably exclude, this one you should probably exclude, but you should review it manually, and this one you should probably include, but you should rate it, look at it manually, etc. And by doing this process, creating this test set, and then iterating over the test set until I got nothing back out of it that was saying, this needs to be eliminated, I was able to pretty quickly identify my problematic MRIs, and I was fairly confident that the ones that were not identified, the ones that were identified as essentially good, not flagged, that they were safe. I checked about 20% of them, and they were all fine. The ones that didn't work though were ones that were really obvious, really obviously didn't work. There were motion artifacts in the image, and they clearly showed up on the FreeSurfer parcellations, but otherwise FreeSurfer didn't return an error to me, so I wouldn't have known. That, for me though, quality, I would recommend. Very useful, just a little bit of effort to create your own training data set to make sure that it's relevant to your data. I'll actually post a link to that in the chat as well.
I feel like I just want to summarize a little bit. Also, too, if you have a large data set and you're working in a lab and other people might be using this data set, you should definitely join forces. And again, this goes back to just track everything carefully so that kind of once your lab does this once, you don't really have to do it again. If you change the pipeline, you'll of course have to do it. So just keeping that in mind, band together. It's also best if you try and integrate both visual and quantitative metrics to QC your data. And visual, it's best if you have more than one rater and you can compare and you have a really outlined system of what you're doing to what counts as not so good. And then finally, it's also great to QC at multiple different stages. So you QC the raw data, but you also QC as many times as is possible and reasonable within the processing pipeline. Yeah.
One thing when we're doing about Visual QC, I want to give a shout out to tomorrow's BrainHack project, because I convinced Jerry from our group, who's been working on essentially a tool to make Visual QC pages and place it for pipelines that don't have Visual QC pages. And feedback on that tool and how to make it more user friendly so that other people can use it. Totes, I think, gonna be amazing and helpful and really good for all those situations where sometimes the pipeline creates QC pages that are useful for you, and sometimes cool pipelines exist and people forget to actually build any kind of QC process into the new tool, which is a pain in the butt, because actually the new tools are the places where we really do need some kind of a QA process. What was I going to say? Oh, we're running a little bit over time, but I want to give us a chance to sign off. So very quickly, if you had a time machine and you could visit your former self, what would you want to tell them about the scientific journey they're about to embark on in grad school? Or maybe you don't want to speak to that person.
Maybe I'll just start. I would just say, very relevant to BrainHack as well. Use the resources that are around you as much as possible, and ask for recommendations. So sometimes things are overwhelming. There's so many directions you can go in. Ask people who are wiser, or people who you also respect what are doing, what they recommend to focus on to kind of help you direct where you're going. It's also a great time to learn. Yeah. Also, I would say we learn a lot about the how to do things and what you're doing. But it's also a really good time to think about and learn about the why of what you're doing. A bit of how we got to, or why we got to where we are now, and how your research is kind of positioned in kind of the history of research, or what's going on in your field, but also kind of across fields. I wish I told myself that. I wish I could tell myself that.
Any additional comments, Nipona, Arnie?
Yeah, sure. I know that we're over time, so I'll just say really quickly, I don't want to reiterate Grace, but I realize I might be. I was just going to say, understand what you're doing and why you're doing it, and do almost all things, though perhaps not all things, well. I also would just say, don't be at all embarrassed about half-baked code or your coding ability. It is okay. It can't be worse than what people have seen before, I assume. And then attend events like BrainHack. And Aaron, I think Nathan, Grace, and I all started at CAMH at the same time. And right away, you embraced us into events like BrainHack and the Scientific Computing Working Group. And I think I can speak for all of us when I say I'm sure it was key to our development and motivation and sanity at times as well. So I'd encourage everyone to stick around Aaron and all the others that put on this event. Thank you so much, Aaron.
Oh, I didn't know, Nathan, if you want to add something?
Yeah, sure. I'll be really quick then. I know we're over time, but just for myself, what I would tell my younger self is focus on the things that bring you joy. And try not to think too much about the things that bring you great irritation, and you'll make it through.
That's great advice. So I want to tell everybody in the audience to give a big collective round of applause to our speakers, because one for this amazing informative discussion, and two for just coming to the end of what is a very exciting academic journey for you. It might not, yeah, it's very close. You're so close. You're almost done. And we really want to thank you. And we want to invite you to come join us for some Among Us games and some wandering through Distillery District, and join us for the rest of the event. So best of luck on your defenses. Big applause. And we will follow up after the break with a discussion about bids and bids apps, which hopefully after this hour you've realized that it's even more important to stick around and learn about those things. So it's pretty exciting. Thank you again. Big congratulations and big applause. And we're seriously cheering for you next week. I'm so excited to celebrate with you.
Thanks, Erin.
Thanks so much, Erin.
And thanks everyone for listening. I hope it was helpful.
Thanks everyone. Bye.
Bye.